How are we supposed to figure out the difference between these three minerals? They are all the same color. You had this earth science class last year. How did you do this?
Well, you have to look at different properties of the minerals. What have you looked at so far?
I started off deciding if it was metallic or non-metallic. These aren't shining or sparkly like a metal, so they are non-metallic. Right so far?
Yes, keep going. What else did you figure out?
I did a hardness test, sort of a hardness test anyway. I don't have all the tools to check the exact hardness, but I know that these are harder than my fingernail and a penny.
Good start. You could be more precise with that, but keep going.
They are white.
Yes, they are white. But tell me, how valuable is the color of the mineral in determining what it is?
For some, it is great.
Such as?
Azurite for one. It is a copper oxide and it is always blue. They even named a shade of blue for it. Ever heard of azure blue?
Okay, so you have one. Any more?
Sulfur. Sulfur is always yellow, a bright yellow, a very distinctive yellow. That is the way a mineral should be, easy to tell by a distinctive color.
Alright already, stop the list. So there are some that are easily identified by color, but that doesn't help you any with the three white ones that are sitting in front of you, does it?
No, but I was still right about the color. Do you have any suggestions on how I go about figuring out these minerals?
So far you have their general appearance, that they are non-metallic, their hardness sort of. That still leave quite a few possibilities.
I know that much. Tell me something I don't already know. Something like, what do I do next?
I think it is time to look at cleavage.
I tried that once, but my mom caught me and I was afraid she was going to skin me alive. Besides, I have to get this homework done. Try to focus here.
Gross, get your head out of the gutter. I am talking about the kind of cleavage that minerals have not what you were thinking of.
How was I supposed to know? How can a mineral have cleavage? Minerals don't have, well, you know.
I am going to give you a benefit of the doubt and awesome that you just haven't gotten to the part in the book that talk about cleavage. It is either that or you are massively creepy.
I'm not creepy. My teacher may have assigned us a reading from the book, but I don't always read the assignment exactly when I should.
Let me give you the condensed version. Take a look at those mineral samples. Look carefully and tell me if you see any flat and sort of shiny sides on any of them.
This one has a bunch of shiny sides, but they are all curved and go in many different directions. It almost looks like the way thick glass breaks.
That is called conchoidal fracture. When that mineral breaks, it does so along curved surface that can go in any which way. How about the next mineral?
This one looks like it breaks along flat smooth surfaces. It looks like a box.
That mineral has cleavage. When the mineral breaks, it breaks along planes of weakness. On this particular mineral, those planes are at right angle to one another, like a box.
Why does it do that?
It has to do with the way the different elements that make up that mineral bond to one another. Some bonds are strong and some are weak. When pressure is applied, like hitting it, it breaks first along the weaker bond.
So how about this last mineral? It looks kind of like a box, but a box that has been squished over. The flat surfaces are not all perpendicular to one another.
Right, you are getting the hang of this. Cleavage is another characteristic of mineral that can help you identify them.
Great. So, what are the names of these minerals?
I'm not telling. I will give you tools, but not answers. This is your assignment, not mine.